Okay, one last part we have before we finish the bundle of May, which are 4 videos or 4 parts. Each part is about 27 to 28 questions. Three previous parts are already published so far. This is the fourth and last one. I believe there will be no upgrade in June or July, mostly, because the previous bundle of April was for questions to be discussed starting from February. So Feb, March and April were all the same questions. In May there were some new questions available to discuss or talk about that might be good to you in the real environments or in the exam, online exam and so on. Okay, so maybe for May they will also be valid for 3 months. Okay, so question 83. So far, what is an advantage of the DNA center versus traditional device management? Okay, so it supports numerous extensibility options, including cross-domain adapters and third-party SDKs. This means that when there is a DNA in your network, having a DNA and the DNA is managing everything, this will support some extensions in the future by adding a lot of new devices, new features, new protocols, new adapters or third-party SDKs and so on. So yes, DNA does support that. That's correct. It supports high availability for management functions when operating in a cluster mode. That is correct, but this is not something to compare between DNA and traditional management. This is something to compare between the DNA of Cisco and another controller, another appliance from another company. This is good to be compared from that perspective, but not from the management perspective with versus the traditional management. It's a correct information, but not for this question. It enables easy auto discovery of network elements on a brownfield. This should be elements in a brownfield. Brownfield deployment means that you have a network that's already operated and already working and functioning normally, and then you buy and operate and install a DNA. This is not really good or lovely for the DNA to operate and have discovery, because DNA likes to operate in a greenfield when you deploy a new DNA device, and later you'll start adding the new devices that all of them do support the license of DNA. Okay, and it's designed primarily to provide network assurance. Not primarily, yes, DNA does provide network assurance, but this is not something really to compare. It's not really that primarily. But also correct. These are not B&D, are not false informations, but from the perspective of the question or the trick of the question, A is correct. We can choose A for now. Okay. B, while examining excessive traffic on the network, it's noted that all incoming packets on an interface appear to be allowed even though some access lists are applied. Why? 2 reasons. The meaning that you have a router, you have an interface, this interface is receiving excessive traffic, so that there are some access lists deployed on that interface. Why there are a lot of traffic? There should be some traffic to be filtered at some cases. Why all the traffic are passing? Okay, the packet fails to match any permit statement. Okay, if the packet fails to match any permit statement, then the deny any will match it. All the traffic will be dropped. I'm sorry, this is the third video to be recorded in a row. I'm starting to feel sleepy. It's late at night, of course. Okay, so the failing to match permit will cause you to match the deny, then all the traffic will be denied. This will not cause excessive traffic. This is nonsense. A matching permit statement is too high in the access test list. I'm sorry. This means that in your access list there are a lot of permit, and so on, a lot of permit statements, causing a lot of type of traffic to be permitted. Possible. The magic permit statement is too broadly defined. If you did not define or if you did not match the types of traffic exactly, this could pass some traffic, but not all of them. The access list is empty. If it was really empty, not even with the deny IPNNE, then everything is permitted. If even the deny IPNN is not there, then everything is permitted. A matching deny is too high. If a matching deny is too high, then everyone will be denied. Okay, so if because it's a choose two, I will take B and D. If it was a choose three, then I would take C also, because it might be correct depending on the scenario and the real statements inside the access list. How do traditional campus device management and the DNA differs regarding deployment? A Cisco DNA device management can deploy a network more quickly than traditional campus device management. Yes, this DNA can control and manage your network much faster than other device than traditional way by controlling everything from a single centralized point. Traditional devices allows to scale more than DNA, the opposite. Cisco DNA device management can be implemented at lower cost. No, DNA is very expensive, especially if it was with some cluster enabled. That will be a ton of money. Traditional campus device management schemes can typically deploy patches and updates more quickly. No, if you have software upgrades and some patches to deploy on your network by using the traditional campus, you would need to access every single device at a time, upgrade it at a time. By using DNA, you will upgrade all at the same time. So A will be the correct only answer for question number 85. Okay, question number 86. How do AAA operations compare or differentiate? Authorization provides some access control, meaning that it will limit your privilege. That is correct. And why did that become this way? And authentication tracks the user services, like build some statistics about what the user is doing, what it's allowed to, all the numbers about that user. This is not authentication, that should be accounting, so I'm sorry. Authentication identifies the user, yes. Accounting tracks those services, yes. Accounting tracks the services, yeah, but authentication provides the control. No, that should be authorization. Authorization identifies the user, that should be authentication. Authentication provides control, that should be authorization. So only B is correct for this question. What is the difference between a local access point and a flex connect? I did talk about that either in part 1 or part 2 in this series, and definitely talked a ton about this comparison in chapter 6. When you have an access point, a local mode access point that is connected somehow to this WLC wireless controller, some switches are in the way. If they are connected together through some tunnel called the CAP WAP tunnel, if it was the local default mode for the access points, then whenever something happens to the CAP WAP, this device will disconnect all the clients connected to it, all the wireless clients, because it cannot make a decision by itself. So to fix that, Cisco enabled the Flex Connect operation mode so that this device will continue operating even if the CAPWAP fails. So local access point creates two CAPWAP tunnels per access point to the WLC. Yeah, that's correct regarding the local, but this is nothing to differentiate between the Flex. This is an L, a Flex Connect and an access point and the local. Flex Connect fails to function if the connectivity was lost. No, Flex Connect fixes that. Flex Connect bridges the traffic from the access point to the controller when local switching is configured. No, this is a default statement. Local mode causes the access point to behave as if it were an autonomous access point. No, an autonomous behaves without controller. A local needs a controller, so they are very different than each other. So this useless question is asking about the difference between Flex Connect and local, yet it only mentions something about the local, unfortunately. Okay, so we can answer only A in the exam because A is the only correct statement here. Which function does the range of private IP address perform. It allows multiple companies each to use the same addresses without conflict. Definitely correct. This is chapter 1. Provides a direct connection for hosts to the internet. No, that would be public. Ensure that NAT is not required. No, when there is a private, then we would need NAT to translate it to public. Enable secure communication to the internet for all external hosts. No, that would be IPsec, not the regular IPv4. So A is the only correct answer in this question. 89. What event has occurred if a router sends a notice level to the syslog? The notice, which was the second less important message after debug. Okay, debug and then N for notification or notice, and error and lot, emergency, critical, alarm, and so on. So if a TCP connection has been torn down, this will not be a notification. No, this is a disaster. An ICMP connection has been built. This is too obvious, so this will be a debug. An interface line has changed status, definitely correct. Just try login to your router in Backtracer and do a no shutdown for an interface. You'll have a syslog message, and the level of that will be N, the notice or notification. If a certificate has expired for the firewalls or IPsec or those security things, encryption, no, I believe it will be more than notification, but not this. C will definitely be correct regarding creating a syslog message from the notice level. This is not clear. I will read it to you. An admin configures 4 switches for local authentication using passwords. Okay, for console that are stored in a cryptographic hash. Cryptographed. Okay, the 4 switches must also support SSH enabled. Yeah, which switch config is correct? I have 4 switches here, switch 1, 2, 3, and 4. Each one is configured differently. Only one of them satisfies those requirements. Switch number 1 had enabled line V2I from 0 to 15 for SSH, but disabled the login local. We need a login local for this one, the local. Switch 2 has created some usernames like username admin, and the password is ABCD. This is a password, not a secret, so it will not be cryptographed. Incorrect. Username admin with secret something, and username admin 2 with secret something. So far it's encrypted. Had enabled line V2I, that is good so far for SSH, and enable login local for the local access, very good. And the fourth one, secret and secret, good. Enabled line console 0 and login local, but nothing about line V2I, so SSH will not be enabled. So only switch 3 has the correct config, and its config should be copied and pasted in all the other 3 switches to operate as it should be. What are 2 fundamentals of virtualization? Number 1, the environment must be configured with one hypervisor that serves solely as a network manager to monitor SNMP traffic to become an NMS. Yeah, we can do that in virtualization, definitely. It allows logical network devices to move traffic between virtual machines and the rest of the physical network. This is not just by virtualization and virtual switches. You will also need routing. It allows multiple operating system and application to run independently on one physical server. This is the big benefit of virtualization, just like we've talked about in chapter 1. It allows a physical router to directly connect an NIC from each machine. No, you will virtually in the virtual switch and the virtual NICs to connect to those virtual machines, and then to bridge the ports of the virtual switch to that physical router, not this way. It requires that some servers, virtual machines, and network gear reside on the internet. No, that's not a requirement. No. So A and C are 2 correct statements, and the question asked for 2. So here is your 2 answers. Refer to the exhibit. What two conclusions should be made out of this config? Okay, show a spanning tree to VLAN 30. So it's a per VLAN spanning tree because this is spanning tree for such specific VLAN. So there is a tree for that specific VLAN. So it's a PVST per VLAN spanning tree. VLAN 30. The mode is rapid, so that would be a rapid PVST, and in Cisco it's always a plus, not a normal one. The priority, the address, the coast, the port, this one leads me to the root. Nothing says that I am the root, so this switch is not a root bridge. It goes or connects to a root bridge later. And let's see, the designated port is fast Ethernet 2 to 1. A designated port will be the port of the root device itself. No. This is the root bridge. No, nothing says that this one is a root bridge. The spanning tree mode is R PVST plus, yes, or it's a PVST plus, no, it's rapid, not a normal one. The root port is fast Ethernet 2 to 1, yes, because this device connects me to the root port, a root bridge. Okay, so it will be a root for me, for the other side will be designated. That will be CNA for 92. Question 93, a router served these 5 routes from different route sources. Which two does it install in the routing table? Good. So it received 5 routes, different routes. All of them leads to the same network. 2 of them only will be installed in the table. Let's see. So the more specific will always be installed, the smallest subnet mask. So 30, 30, 16 is big, 30 and 32. 30 and 32 are bigger than 60, so 16, so I'm sorry, leave this one. From these 4, I will have the longest match will be installed definitely, which is 32. So the AHRP wins, AHRP of 10.0.0.1/32. And from those 3 others, one of them should win the battle. Since all of them have the same subnet mask, then the lower ID will win. IBGP have an ID of 200, RIP have an ID of 120, OSPF had an ID of 110. So this guy will win the OSPF with /30, not OSPF with /16, but with /30. This is something about the beginning of chapter 3, and it should be simple, I hope. The network admin wants VLAN 67 to travel untagged. Make it native. No other solution you have. Okay, so let's see. 67 should travel between these 2 devices untagged. So it will be untagged here since those are access ports, because whenever a frame try to cross an access port away, the tag will be removed from the frame and pushed to the PC. So it's already untagged here, but in this path between these 2 devices, how to make it untagged? By making VLAN 67 native, so it will travel untagged. Okay, so access it to 67, no. Trunk it to 67, this will tag it. Private VLAN is not about our study, it's not really that complicated. Native the VLAN 67, yes, thank you, that would definitely be correct. 95. What are 2 differences between optical fiber, my friends, and the copper cabling, which is the world's friend? A light is transmitted through the core of the fiber, yes, light and laser sometimes. A BNC connector is used for fiber connections, no. I believe BNC was only for the serial ports, old coaxial ports. Fiber never uses that. It uses SC, LC, FC, CS. I believe there is something called CS also, and some MPO for higher capacities. Later some DWDM, but not a BNC. The glass core component, which is that glass of fiber of a glass that's passing, is incised in a cladding. Yes, you can see the anatomy of fiberglass, fiber optic. Fiber connects to physical interface using RJ. No, this is for copper, definitely, you know that. Data can pass through the cladding. If it was to pass through that cladding, this is my glass fiber, and this is the cladding that is coating it. And what happens in the multimode is that light keep keeps hitting those walls of cladding all the way until it reaches the end. So if light passes this way, that passes the cladding, then data will be lost before reaching the other end. So this is nonsense. Okay, so A and C are correct regarding question number 1,095. I'm sorry, and let's go to 96. Which two minimum parameters must be configured for OSPF between two routers to operate? Two things that you cannot not configure. You need an area, you know that. An MD5 authentication key, this is an optional for future. An IPv6, yes, if it was an OSPF v3, but since it's OSPF v2, then we would need an IPv4, not an IPv6. A process ID, definitely. A stop flag, not in normal conditions, no. So A and D are mandatory, and it's about to choose two, so that would be good, I hope. 97. After the config is applied, the two routers fail to establish OSPF neighbor adjacency. Why? Okay, for R1, this is R1, interface giga11, this is the description, some IP address /30, no problem, and it changed the hello interval to become 5 instead of the default 10, no problem so far. This is router OSPF process ID 1000 with this ID and has advertised this correct network in area 0. The other guy says same interface, some description, and good valid IP address from the same network. OSPF 1001, even if the process ID are mismatched, it will operate since they are both in the same area, correct. A passive interface default. Now all the interfaces of R2 are OSPF passive interfaces, meaning that whenever they receive the hello message from another guy, they will pass it, they will not reply. So no neighbor adjacency will happen through this interface. I'm sorry. Okay, passive interface default, but no passive interface for giga11. So all the other interfaces on this router are passive except for this one. So if this interface is received the hello message, it will reply. Then no problem, we passed this problem, it's fixed. But then what is the mistake here? The mistake is that the default timer for a router, when you do not mention anything about timers, is 10 seconds for the hello timer and multiplied by 4, 40 seconds for the dead interval or the dead timers. Okay, so it's 10 here and it's modified to become 5 here. So this is in hello time and the dead time intervals mismatched. So but the router IC is mismatched, they should be mismatched. R2 is using the default hello timer. Yes, as you can see. Okay, I hope that was clear. Good so far. How do TCP and UDP differs from the perspective of reliability? TCP is reliable, UDP is never reliable. TCP is a connectionless, don't read more because it's a connection oriented, no exceptions. TCP does not guarantee delivery. TCP does guarantee delivery. TCP provides flow control to avoid overwhelming a receiver by sending too many packets at once. And UDP sends packet to the receiver in a continuous stream without checking or sequencing. The meaning here is the three-way handshake. The TCP do always ask the other guy, are you there? Are you available? Can I send you? Please acknowledge. I will acknowledge your acknowledgement. So far. Then after that process is done, it will start sending data. So this is good to guarantee that the other guy can receive, is there, is responding to me, and then I will receive. UDP will just send, and that's it. I don't care if you received my message or not. I don't care if you understood me correct or not. I will always send to you. This is UDP. But TCP is very sensitive and appreciable and a good guy, but it's a slow guy, okay, unfortunately. But this is the correct statement. TCP uses windowing. UDP provides reliability. No, UDP does not provide reliability at all. Does it TCP uses windowing? Yeah, I believe both of them do use windowing, meaning the ports. A packet destined to this one, which static route does the router choose to forward the packet? Okay, let's see. IP route 10.10.1.0 slash 28.240 slash 28 have an increment value of 16, meaning that this network starts with 0 and ends with 15, so 22 is not included. I'm sorry. IP route 10.10.1.16 slash 30, and slash 30 gives you 4 IP addresses, dot 16 as a network ID, dot 17 and 18 as a valid IP addresses, dot 19 as a broadcast. So the last IP address will be 19, not 22. I'm sorry. 10.10.1.20 slash 30. Okay, so this will start with 20, 21, 22 for using, and 23 for broadcast. So 22 is included here, definitely will work. And dot 20 slash 31, which advertises only the dot 20 itself, just like the slash 32. And this is rarely used, so this will be incorrect also. Okay, C is the only correct one, the only correct command to route to do static route. Okay, question 100. Router R1 fast Ethernet 00, this interface here for this router, cannot ping R3's FA01, which is this interface of this router. Which action must be taken on R1 only to solve this? Okay, in R1 show IP route, I can see that there is only a C connected. There is nothing about a routing protocol, not S, not D, not an O, not an a RIP, an ISIS, not even BGP. So definitely R1 will not be able to reach a far broadcast domain because there is no routing protocol here. In R3, you can see that there is an S, which is a routing protocol, advertising to 10.10.10, which is here. So this one is sending a static route to him, but you know in static route we should also log into R1 and send our static route back to 20.20.20.2, and its next hop will be either this IP address or egressing this interface. So we would need to add a static route here to this one, and that will be which option? That will be set a default network. No, it's not about a default network or a default gateway. We need a static route to a further network. Configure a static route. Sometimes this works, but not in this. Sometimes this solution works, but not in this case. Configure a static route with FA01 as an egress interface to reach this network. Can this be correct? FA01? No, I'm sorry, because this is FA00. So it should be the egress should be FA00 or a next hop of 10.10.10.2. Let's see, let's hope. Yep, configure a static route. Give me my pen. Give me my pen. Configure a static route with 10.10.10.2 as a next hop to reach 20.20.20/24. Definitely correct. Just like the tons of lab that we did for a static route back in chapter 3. 101. An engineer must add a subnet for a new office that will add 20 users. Which network and subnet MAC combination can the network engineer use to minimize wasting addresses? Okay, so here is a subnet for this department, for this department, for this department. This new department requires a subnet also. Let's see. Those guys will be of 20 hosts. So on this scale, 1, 2, 4, 16, 32, 64, 64, etc. Only the 32 will be enough for them, and on the right we will have this line 0, 2 zeros, 3 zeros, 4 zeros. So 32 minus 4 will be /28. So we would need a network with a /28. 1, 2, 4, 8, 16. What are you doing? 16, 8, 4, 2, 1. 1, 2, 3, 4, 5. 5 zeros. We would need a /27 subnet mask for those guys. Okay, so let's see which of those is a /27. This one is 240. This one is 240. Those are /28. Useless. Those guys are /27s. I will use one of them. let me tell you something. To minimize wasting addresses really, and to really hit, like there is an Arabic quote says that hit two birds on a tree with one single rock. How to do that? This network is 10.10.225.0/28 with the increment of 16. This one will ends with .15. Okay, so the next one should be .16, and there it is. .16/28 means that it starts with .16 and ends with an increment of 16 again, .31, and the next one will be .32, the next network. But you see, this is .64 that starts here somehow, somewhere. So there is a gap in subnetting between these two departments, some wasting of networks from 32 up to the IP before 64, which is 63. So between 32 and 63, the increment is 31 or 32. So the network that I need /27 can be 10.10.255.32/27, which will be very beneficial to use it here without wasting any more addresses. So it will be this one. Okay, .48 will start from 48 and will end somewhere in the 70s or 80s. This will duplicate with those guys here. So this one will be the only correct one for question 101. I'm sorry, something happened for that PDF. Question 102. A corporate office uses 4 floors in a building. That should not be here. That should be at the top here. Okay, so these are 4 floors. This is this same like Mega Lab #1. You can see it's already uploaded in English and Arabic whenever you, whichever you like. There is a playlist: CCNA English Mega Labs, this CCNA Arabic Mega Labs. Whatever you like, it has the same lab like this, lab like this one. Floor #1 has 24 users. Floor 29, floor 2 has 29. Floor 3 has 28. Floor #4 has 22. Some of those subnets, which of those subnets summarizes and gives the most efficient distribution of IP and over the router config. This means that, just 1 minute. Okay, so 103 starts here, 104 starts here, 105 starts here. There is something wrong with this slide. I will correct it before I upload it. Okay, I must correct that before I upload it so that you will download the correct one with you and study it. Anyway, so that will be which one? I'm sorry. Yeah, we need to summarize those 4 guys in one single subnet, and that one single subnet will include a number of IP addresses that is enough for those 4 floors. This is a 2 question in one. The first one is designing subnets. The second one is a route summarization. Okay, for the first half we'll be designing 4 subnets, 4 subnet masks for those guys. How to do that? Take the scale of 1, 2, 4, 8, 16, 32, 64, 128, and so on until you whatever number you want, and start from the biggest to the smallest. The biggest is 28. I'm sorry, 29, and then 28, and then 24, and then 22. Oh, this is good so far. Okay, the idea will be then 28 users plus network ID and broadcast ID means a 31 IP address. Which one will be enough? A subnet that gives me 32 IP will be enough for them. So I will pick this one. I will draw a list line on the right. Whatever something on the right will be 0. 5 zeros in a subnet masks mean 27.1. So for those guys, their subnet mask will be a /27. Okay, next. So /27, which gives the increment value of .30. Okay, next 28. So 28 plus 2 will be 30. And which one is enough here? Also the 32 is enough, 16 is not. So I will also have the same line, the same 5 zeros, the same /27 for those guys. The next 24 plus 2 will be 26. Who is enough here? Seems also 32, so I will take 32, which gives me the same subnet mask. Last one, 22 plus 2 will be 24. 16 is not enough also, so slash 27 for the fourth time. To design this building, you will need internally inside each floor to have a network of slash 27. Okay, because it gives a minimum of 32 IP address, a maximum of 32 IP address. Okay, and to summarize those 4 floors, you will need a network that includes the summation of those. No, the summation of those, the increment values. Okay, because this floor has a subnet of 32 address. Yes, we are using 24, 26, but in total it's a 32. So 32 for each floor, multiplied by 4 floors will give me 128 IP address. So of those network, one of them should support 128 IP address. Slash 26 gives 64 IP address, not enough. Slash 24 gives 250, could be enough, but each floor will use the slash 28. No, we need the slash 27 for each floor. Slash 23 gives us 510 valid IP address, could be good, but says that each floor will be a slash 25. No, it should be slash 27. Slash 25 will give me a maximum of 128 IP address. Good so far. And each floor should be 27. Yes, we know that. So you are our friend. D is the correct one for this question. I hope that was clear for you. Really hope that. Okay, unfortunately, the slide, something happened to the slide starting from 102, 3, 4, 5, 6, 7. Oh God, 8, 9, 10. 10 is good. 9 is good. Okay, until 108. Okay, I will correct that before uploading the slide. Even if it's uploaded already, I will check the uploaded one and fix it. Okay. 103 says, by default, how does EIGRP determine the metric for a route? EIGRP have a very big equation of a lot of variables and numbers, and it's using its 5k values, like from k1 to k5, like delay, bandwidth, reliability, transmission and receiving capacity or capability, and MTU. Okay, fixed. Though these two are interchangeable and you can modify it or manipulate their values to control the traffic. So we need to change one of them or both of them. So it uses the bandwidth and delay values for a path. Yes, this is what I'm talking about. It uses a default metric. No, this is not OSPF. It uses a reference bandwidth. No, this is not OSPF. It counts the number of hops. No, this is not RIP. These are some logical things to know about protocols in the previous CCNA, not in this CCNA, because this CCNA talks only about the OSPF and static. Okay, refer to the exhibit, we'll see it in the next page. Which config issue is preventing OSPF neighbor adjacency? Let's see. Okay. Show run for R1. Interface 1.0 has an MTU modified of 1600 and an interface slash 30. OSPF, all the interfaces are passive, a disaster, but no passive for 1.0, so this one is working normally, and some network is advertised, no problem. The other guy here, this is interface 2.0, has a good IP that's from the same domain and a different same process ID, no problem. A unique ID, good. Also passive interface default, but except to 0, so this port should operate normally. Lastly, advertising a correct network in the same area. What's the problem here? The problem is that this interface has a modified maximum transmission unit of 1600, but this one is by default 1500 and it has not been changed. What does happen between two routers to establish neighbor adjacency? It's a down, initiate, two-way, xstart, exchange, loading, full, just like we have talked about in chapter 3. Whenever there is an MTU mismatch between two interfaces, the relationship will be stuck at xstart. Okay, it will cross initiate and two-way. Once the X-start starts, they will not be able to exchange LSAs, so it will be stuck at X-start. That's because of the MTU mismatch, and thus the neighbor adjacency will not be completed. Okay, so R1 has a larger MTU. Yes, yeah, that is correct. This one is correct. That's passive interface, not incorrect command. No, not an area. This one. So that will be D for this question. 105. What are the two roles of a DHCP? Let's see. That is really annoying. Okay. The DHCP server offers the ability to exclude specific addresses from the pool. We know that. We configured that a lot of times before. The DHCP client can request up to 4 DNS servers, only 2, the primary and secondary. The DHCP server assigns IP addresses without requiring the client to renew them. No leased line is enabled by default, and it is 24 hours in Cisco's routers. So the route server will ask you every 24 hours, do you want to renew or are you away? So this is incorrect. The DHCP server leases client IP address dynamically. What does that mean? Leases client IP address dynamically. Not sure. The DHCP client maintains a pool. The client maintains a pool. No. Only the server has a pool. So the DHCP server leases client IP. This is the same thing like this one, which saying that the server assigns an address with requiring the client renew, and that requirement is dynamic. Yes, because the lease time is already by default enabled in the routers, and its value is 24 hours and can be modified. So that would be A and D. Okay, 106. How does CapWap communicate between an access point and a local mode? Through wire devices. In the way, the access point must directly connect to the controller with a copper cable. No, it must not be. It's not a must. It's not a must. There can be a tons of switches in the way, no problem. The access point must not be connected to the wired network because this will create a loop. The access point must be connected to a wired network in the normal operations. Okay, in the normal operation, must be connected to the DS, the distribution system, which is the wired network. The access point must be connected to the same switch of the controller. No, not really condition. The access point has the ability to link to any switch in the network, assuming connectivity to the controller. Thank you. That is correct. Yes, that would be D, and D is correct regarding this question. 107. Refer to the exhibit. We'll see it in the next page. Which action is expected from S1 when it receives an untagged frame on interface 01? Let's see what untagged frame, and let's see what can happen. It's really annoying. Okay, so all of those need to be corrected. Yes, show on interface giga01. It's access for VLAN 11, so it's tagged on 11 in the domain. Then it's trunked. Mode trunk, so this will be erased. This interface is trunk, not in access anymore. It's allowed VLANs are 1 to 10. It's encapsulated. VLAN 5, which is untagged, will travel freely, and the mode is trunk. So whenever there is a frame that comes to this interface with no tag, this one will be considered as VLAN 5. So it will process in VLAN 5, this one, okay? Because it's also the untagged one. 108. What are two reasons for an engineer to configure a floating static route? Why would you configure a floating static route? Tell me in chapter 3. Because static route is not like dynamic routes. It does not support redundancy and high availability. So whenever the static route goes down, the network goes down. So to automatically route traffic to a secondary path when the primary path goes down, yes. To route traffic differently based on the source IP of the packet, no. to enable fallback static routing when a dynamic routing protocol fails. Will a static route appears after a dynamic protocol fails? What do you think? If static route will appear in the routing table after the dynamic, or static are always there as long as they are configured, no dynamics. This special case can happen if you have configured a floating static route with an administrative distance of 113. Okay, and there was an OSPF in your table, and you know OSPF has an ID of 110, so this one will be hidden even if the primary static route fails, because the primary static route has an ID of 1. The next greater one will be 110, and the next greater one will be 113. So you will need the primary static route to fail, the dynamic OSPF to fail, only then this one will pop up in the table. So C can happen. D, to support load balancing? No. To use load balancing in a static route, you will need to specify the same route to different destinations twice by using the same AD, not a different AD, not a floating, to control the return path of traffic that is sent from the router. No, this is nonsense. Okay, so A and C are correct, and this is what the question is asking about. 109. Which type of route does R1 use to reach? The same question every time. You know that, okay? So 10.10.13, this is 10.10.10.0, could be bus/30. So this one is not including this one. Leave it. 10.10.13.0/25. Yes, /25s have 128 IP inside it, and this guy is included. Could be 10.10.10.16/30 will not include it, and 10.10.13.144, this is way beyond that. So only this guy here includes this IP address, and this type of routing is called network route. Okay, a normal network route. This is not a default of zeros. This is not a host of /32. This is not a floating because it's not an S with an AD of 2. This is a normal network route. Okay. 1010. How does Cisco DNA Center gather data from the network? Let's see. Network devices using different services like SNMP, syslog, and streaming telemetry to send data to the controller. That can be correct. Device establishes IPsec to exchange data. No. Devices uses the call home protocol. No, this is for applications and other stuffs. The Cisco CU analyzer tool gathers data from each licensed network device and streams it to the controller. Yes, that is also correct. Since it's a choose one, I will choose the new specific feature created for DNA more than other devices. Okay, this is how about the DNA gathers. So it will be the DNA tool used to gather information. It's about if DNA is something. But what about the licensed devices? Licensed devices of Cisco are the new Catalyst and the new series of devices that Cisco have started to publish in the market in the past year or two or something. And all of them supports DNA, like the series of 9000, or maybe we can call it the 9300, 9400, 95, and 9600. All of those are a series of devices that all of them do support the DNA and licensed to operate normally and immediately with the DNA center, and can be controlled completely by that DNA center. Okay, 111. What is the difference regarding reliability between TCP and UDP? We had a familiar question before. TCP is reliable, yes, because it's a connection oriented, yes. UDP is not reliable because it's a connectionless protocol, yes. TCP is not reliable, no. TCP is reliable, watch out yourself. TCP is not reliable, no. TCP is reliable because it's a connectionless, then how will it be reliable? Okay, so only A, and this is something definitely mentioned back in chapter 1. I drag and drop, yes, drag and drop the characteristics of networking from the left into the correct networking types on the right. Okay, this one is a controller based networking. This one is a traditional networking. Maybe you cannot read that, I'm reading it to you. This one is focused on network. This is the traditional. This one is focused on devices. No, this is mistaken. Yeah, because focused on network will be control based that sees and visions all the network on devices will be traditional network because it's per device. User input is considered as a config. This is the traditional when you log in and configure the device. A user input is considered as a policy. Yes, you establish a policy and leave the device to apply it later. Uses whitelist security model and uses a blacklist security model. I have heard about whitelist in the traditional networks before, in firewalls, so I will give it here, and the last one will be here. I have no other choice, and I hope that is all the 6 of them are correct. Okay, and that is that. Yes, that is very good. Okay, so this is the end of this video. This is the end of part 4. This is the end of May's bundle of 2020. This is the end of this upgrade that was published back in May, or currently in May. I hope all of that was informative enough for you, and I hope that this will be enough for the upcoming 2, 3, or maybe 4 months. I hope that really, because it's a lot of questions to study before the exam. But if you have studied the complete course and you have implemented every single lab by yourself, or if you have studied the official cert guide from Cisco, then these are only a review to you and you will only enjoy them and you will not waste time on them. You will just be like minutes of reviewing questions and memorizing and helping your brain. Okay, so thanks a lot for watching. I hope that all of those were really informative and beneficial and useful for you, and I hope to see you. Actually, I will see you soon by recording Mega Lab number 2 right now at the end of May, and then Mega Lab number 3, and then the CCNP Enterprise Core exam. It's actually the CCNP and CCIE in Core 350-401 exam. So thanks a lot again, and goodbye.